I'm going to take a look at median and mean. So in this section where we discussed central tendency, we talked about three ways to define the center of a distribution. One way is to define the center of a distribution by finding the balance point of the distribution. The second definition is the value whose average absolute difference from all the other values is smallest. And the third was the value whose average squared difference from all the other values is smallest. The mean is the point on which a distribution would balance. So in the figure, the fulcrum, the top of the triangle, is the mean of that distribution. The median is the value that minimizes the sum of absolute deviations. Here, the absolute differences from the arbitrarily chosen number 10 are shown. The total is 28. The sum of the absolute deviations from the median of 4 is only 19. Of course, the value that minimizes the sum of absolute deviations is also the value that minimizes the average absolute deviation. The mean is the value that minimizes the sum of the squared differences. Here you can see that the sum of the squared differences from 5 is 151. For example, the difference between the first value of 2 and 5 is 3. Square 3 and you get 9, which is shown in the second column. The sum of the squared differences from the mean of 6.8 is only 134.8. To see this in action, let's apply these principles to a set of 5 numbers. We've got 2, 3, 4, 9, and 16 with their median of 4 and their mean of 6.8. You can see that the distribution indeed balances at the mean of 6.8 and not the median of 4. Here we compare the mean and the median for this small set of data. The median is 4.0 and the mean is 6.8. Looking at the first row, the absolute difference between the value 2 and the median of 4 is 2. The absolute difference between 2 and the mean of 6.8 is 4.8. Squaring these values, we find that the squared deviation from the median is 4, and the squared deviation from the mean is 23.04. By looking at the last row, you can see that the sum of absolute deviations from the median is smaller than the sum of absolute deviations from the mean. This will always be the case, since median minimizes the sum of absolute deviations. On the other hand, the sum of squared deviations from the median is larger than the sum of squared deviations from the mean. This is the case because the mean minimizes the sum of squared deviations. There are two important final points to note when thinking about means and medians. When a distribution is symmetric, then the mean and the median are the same. Moreover, the mean, median, and the mode are identical in a bell-shaped normal distribution.